So we'll talk about measures of center and measures of spread or variability in quantitative data. And there's a few different measures of center. There's a couple of different, and then there's some measures of spread. The one that you are familiar with, and we're going to use this example, by the way. We've got the salaries of 12 employees at a company, and these numbers are in thousands of dollars. So 39 is 39,000, etc. So the mean of a distribution. Mean is the same thing as what word? Average. And how do we find the average? We add up all the numbers and divide by how many there are. And the notation we use in statistics, and I'll get into we'll get into this later because there's a couple of ways to show mean, but for now, we're going to use this called X bar. And it's the sum of the data values divided by the number of data values or in a more formalized formula, this is the Greek symbol representing sum. And yes, it's called sigma. And then data values, we would say xi. And then we divide by how many data values there are. Or you may see it like this. 1 over n times the sum of all the data values. Okay? This is actually a formula you will always be getting. Always be given. Add up the numbers. Calculator. So find the mean of this distribution. You add up all the numbers, the data values in the list, all 12 of them, and divide by how many there are, 12. And that would give us approximately 50.1. But remember, units are very important in measures of center and variability. So this would translate to $50,100. That should be your final answer. You need units for mean and median, which we're going to talk about shortly, and the measures of variability. Okay, so that's pretty straightforward. The median of a distribution. We refer to it as the midpoint, or it's the middle number in a distribution. So obviously, to find the middle number, the data has to be organized from smallest to largest, largest to smallest. We usually do smallest to largest. Okay. The number in the middle depends on how many data values there are. If there are an odd number of data values, the median is one value in the middle. So don't write this down yet, but if I wrote 5 numbers, 7, 3, 8, no, sorry, I'll do it in order. 3, 4, 7, 8, 11. Okay. What's the median? 7, because it's the number in the middle. Okay. and because it's an odd number of data values. How would you find the position of the middle number if there were 51 data values? The way you can do it when there's an odd number, divide by 2 and then round up to the nearest number. So 51 divided by 2 is 25.5, which means the 26th number is the one in the middle. Which makes sense, because if there's one in the middle, there must be 25 below and 25 above to make 51. Okay. If there is an even number, like this example is, there's going to be 2 numbers in the middle, and then you have to find those 2 numbers in the middle and average them to get the median. So how do you find the 2 numbers in the middle? Just do the total number of data values divide 2. That will get you the first number in the middle, and then the one after that will be the second. So for example, 12 divided 2 is 6, which means the 6th and the 7th are the 2 numbers in the middle. So 1, 2, 3, 4, 5, 6, and 7, those are the 2 numbers in the middle. And therefore, to find the median, we just do 34 plus 35 divided by 2. And we get 34.5, but we must use proper units and answer in the context of the question. So therefore, it would be 34,500. Okay. Those are the 2 big measures of center that we're going to use. And actually, we're going to use the mean more than the median eventually. Okay. One more example. How do you pull, especially a median, from something like this, or from some other graph? It could be a stem plot, it could be a dot plot. So here we have 55 ACT scores shown in a histogram. We don't know the specific values, we just know 2 of them, the scores are between 9 and 12, 2 of them 12, or sorry, 3 of them 12 to 15, etc. Okay? How would you find what bar the median is in?
Count the bars.
Count the bars?
Mm-hmm. Would that work?
Like how many are in each bar?
Like,
So like say 2.
no, that's 1, 2, 3, 4. Like count the number of bars. Yeah.
Yes, but they're not evenly distributed.
Yes.
Thank you. Thanks for sharing. Where is the middle value going to be? Or what's the position of the middle value? What's the position of the middle value?
55 minutes.
Middle position. 55 by 2. But then go up. What do you get? Sorry? 20.
7. 28.
Thank you. Well, these are all listed from smallest to largest, right?
Yes.
So how many are here? 2, 3, 5, 7, 9, 9. Keep counting until you get to the 28th one. So 3, 5, 10, 17, 26. So there's 26 up to here. There's 9 in here, so that means the 28th one must be in here. Must be here. So the best I can do is the median is equal to 24 to 27, somewhere in there. Okay, be familiar with how to do that. Read that from the graph. And you could do it from a stem plot too. You would do it the same way. Find the position of the middle number, and then from the top of the stem plot, which is the lowest values, count until you get to the middle position, and then you'll be able to find the mean. Okay. Variability. We have talked about range. The range is simply the max value in a distribution minus the mean value. So if we go back to our first page where they're listed in order for us, the max value is 185 minus the min value of 29 gives me a range of 156, which translates to, because we need units again for measures of spread, 156,000. So the range is a very quick way to sort of ballpark how spread out something is, but there are other measures that we're about to talk about that are more useful. Okay. And the next one is called the standard deviation. Standard deviation measures the average distance each data value is from the mean. So we have to use the mean with standard deviation. So, but when I say average distance, a common phrase that we see, typical distance. So how would we find the average distance or typical distance? Well, we'd have to take each of those 12 data values, take away the mean to get the differences, and then average those out. The only problem is, if you average those out, because some are going to be positive and some are going to be negative, they're all going to cancel each other out to 0. And for everything you do, you're always going to get a standard deviation of 0, which is completely useless. So here's what we do instead. Okay? And here's the actual formula. Again, you will be given this on the formula sheet. And we use S and then little x for standard deviation. Well, we're going to take the sum of every data value minus the mean of the distribution. But in order to get away from the positives and negatives to cancel each other out, we're going to square those differences. Then to find the average, we have to divide by how many there are, but that doesn't give us quite an accurate standard deviation. We actually have to divide by how many there are minus 1. Why it's minus 1 goes well beyond this course, so don't worry about it. And then how? But I got to undo that square because now I'm in square units. How do I undo a square? Square root it. So you will see it like that. Could also see it like this, where the 1 over n minus 1, and then this sum of the differences of every data value from the mean squared. And again, this is formula sheet. But actually, you're not even going to have to really worry about that in the formula sheet, because at the end, I'm going to show you how to find it using a graphing calculator. So really, you'll probably never use the mean or standard deviation formulas. I basically broke this down already. So what do we find the differences between each data point and the mean? Find out how spread out each data value is from the center. Why do we square them? Because if we don't square them and add them all together, they'll always equal 0. Because you're going to have a certain number above and a certain number below that when you add them all together, they cancel out. So squaring them makes them all positive. And it also avoids summing to 0 when adding. At some point, we're going to have to square root it to get back to the proper units. Okay. So we find the sum of all these after they're squared and become positive. Okay. This is similar to the mean. Except instead of finding the total data values over the number, we're finding the total differences squared over the number minus 1, over the number of data values minus 1. Okay, so it's similar to the mean because we are averaging all the differences that we found squared. All the differences squared. But like I said, that's not going to give us proper units. That's going to give us money or dollars squared, which doesn't make sense. So that's why at the end, we take the square root. Okay? So you undo the square. And get the answer in proper units. So if we were to use the formula, how would we do that? Well, we would say the standard deviation is equal to, and then we would have to do 12 different things to add together. So we have to take the first data value in the list, which was 39. 30? Oh yeah, the order doesn't matter. Just one of those two. Yeah, so if we go from the original list on the first page, the first data value was 39. Remember the mean we found on the first page was 50.1 squared. So that's one data value. Then we'd have to do the next data value, which was in the original list 34 minus 50.1 squared. and then keep that line going. And then we have to do the third one, the fourth one, fifth, sixth, seventh, eighth, ninth, 10th, 11th, until we got to the last one that was 67 minus 50.1 squared. And then we have to divide that entire sum by 12 minus 1. That's a lot of work. The answer works out to approximately 43.61. Remember, standard deviation, measures of spread, like range and standard deviation, need units. The units in this example we're working with in this lesson is money in thousands of dollars. So our approximate standard deviation would be that. So the typical distance, and that's how you would, yeah, here, I'll write this too, because it says each data value typically varies by $43,610 from the mean. Standard deviations will always be positive. Okay. The higher the standard deviation, the more spread out the data is. Okay. So when you do an interpretation of standard deviation, phrase it like this. Each data value, make sure you use this phrase, typically varies, and then put your standard deviation value from the mean. That's it. Okay. The last one. And this last one is related to the median. We can take a distribution and cut it up into approximately fourths. So we've got a bottom fourth of data, second bottom fourth, second top fourth, and the highest top fourth. We call those quartiles. Okay. Now, each, depending on the number of data values, you can't divide it into fourths with every situation. Like if you had 14 data values, four doesn't go into 14 evenly, so you can't divide it technically into fourths. So it's approximate at times. With the one that we've been using, the 12, you can actually divide it into fourths. So if you do 12 divide 4, it's 3 sections. So this would be the bottom fourth, the next fourth, the third fourth, and the highest fourth in this situation. Okay, so the first quartile, it's the median of the data values to the left of the median in the ordered list. So you've got to do, it's the lower median of the median. The third quartile is the upper median of the median. Okay, this will make sense when we go through it. And the second quartile is the median itself. So remember, we found the median from the first page. It was 34.5. Because these were the two numbers in the middle, and we averaged them out. Okay, so the value of Q2 is 34.5, which means, what does that mean? That means about 50% of the data values are below 34.5, 50% of the data values are above 34.5. Okay, it splits it into two halves, the median. To find the quartiles, Okay? Because we didn't, like, technically neither one of these is the median. The median's here. So I have to find the median of these 6 numbers. And that's going to be Q1. Well, 6 numbers, there's going to be 2 numbers in the middle again, aren't there? So Q1 is going to be the average of 34 and 34, which is obviously 34. For Q3, well, here's where our median is, halfway between here. So there's 6 numbers to the right of the median. I have to find the median of these 6 numbers. Those are the 2 in the middle, so I have to average those 2. So Q3 is going to be 39 plus 43 divided 2, which is going to give us 41. Okay? The whole reason we do that is to find another measure of spread called the interquartile range. And the interquartile range measures the spread or the variability of the middle half of the data. So the data sort of in here. How spread out is that data in the middle 50%? Well, how do we do that? We got to find the median up here, which is Q3, Q1, and so between these 2, that's the middle half of the data. So to find the interquartile range, the formula is, and this is one you're going to have to know, the value of Q3 minus the value of Q1. So it's 41 minus 34, which is going to be 7. And again, we need units. That relates to $7,000. That's the IQR. That's how spread out the middle of the data is, the middle 50%. Okay? Are there any questions about that? A lot of times you're going to be given this information, like along with a lot of times in statistics, you're given a graph of something and you're given something called a numerical summary where it's going to tell you how many data values there are. It's going to tell you the mean. It's going to tell you the median. It's going to tell you the standard deviation. It's going to tell you Q1 and Q3. It's going to give you a whole bunch of information. Okay. This is all well and good, okay? But it is rather time consuming to find. Like if I gave you imagine me giving you a list of 50 numbers and saying, okay, find all 5 of those measures that we just talked about today. Mean, median, okay, range, which wouldn't be bad. But let's say I mixed up all the numbers, they weren't in order. I mean, that would be a test itself. That would take you an hour to do, especially the standard deviation, okay? Fortunately, we got these bad boys to help us. Okay, so hopefully you have a graphing calculator with you. And if you don't, perhaps you can sit beside somebody who does have it. Just to sort of see what they're doing. Okay. Here's a way, and I'm going to pause this. So we talked about 2 measures of center, 3 measures of spread. The mean and standard deviation go together. Because to find the standard deviation, you have to know the mean. Okay? The median and the IQR go together. Because to find the IQR, you have to know the median, and then you have to get Q3 and Q1. Resistance. The median is, and we talked a bit about this like the first day, is resistant to skew and outliers, whereas the mean is not resistance. So imagine, let's say, 5 students. These are the marks they got in the test. What's the mean? 70. What's the median? 70. Okay. But teacher made a mistake. This is supposed to be 100. What's the median? 70. Didn't get pulled. But what's the mean? Well, 140, 280, 380 divided by 5, which is going to give us over 70. So notice the mean gets pulled up, but the median didn't. That's what I mean by resistance. Okay? Because now that's become an outlier, because that's a significant different value than the rest of the data. Okay? Same thing, if the median is resistant, then so is the IQR. If the mean is not resistant, then the range and standard deviation are not. And the mean always gets pulled up or down in the direction of the skew of the data. So if it's right skewed, it's got a tail to the right, the mean gets pulled up higher than the median. If it's got a tail to the left, the mean gets pulled down lower than the median. Okay? And so this, I basically explained it to you. So here's our data. This 185 is clearly an outlier. Okay? It drags up the mean because its high value is given. What did I put? I can't remember what I wrote. More weight, a lot of weight. Sorry, I thought I said more weight. A lot of weight in the calculation. Okay. But for the median, the position of the values matters more than their weight. Okay. So because 185,000 it's basically crossed off right away. So the outlier is not given a large weight in the calculation. And again, similarly for the IQR. So basically it talks about resistance. If there's outliers, it will affect the mean, it will affect the standard deviation. Okay. It could have a slight impact on the median, not much, and therefore not much on the IQR. And on